Hi, I'm Nuwan Janaka from the National University of Singapore, presenting our work on understanding the disparity in literature regarding the effectiveness of pictograms. First, I would like to thank my co-authors Shengdong Zhao and Shardul Sapkota. Pictograms are stylish drawings used to convey information graphically, including illustrations, icons, and signs. Which is more effective for conveying information quickly, text or pictograms? Although pictograms are widely used in daily life, there is no consensus of their effectiveness compared to text. For example, in traffic signals and consumer safety, users prefer pictograms over text. However, in the case of digital notifications, users prefer text over pictograms. Therefore, the effectiveness of pictograms depends on usage context and visualization. Hence, we explored the factors that influence the effectiveness of pictograms on notifications. Our study found that the effectiveness of pictograms depends on familiarity and encoding density. We define the encoding density as the number of words represented by a pictogram. The higher the encoding density, the more effective the pictograms are. In addition, the effectiveness was also affected by environmental lighting. Longer text formats were more visible outdoors. To address our research question, we chose optical see-through head-mounted displays and calendar notifications which provide information on upcoming events. We compared text notifications to icon-augmented notifications. To create icon-augmented notifications, we decompose text notifications into primary information such as event or action and secondary information such as time or location. We then replace the primary information with icons. To address our research question, we conducted three iterative studies in a controlled setting to isolate the factors affecting the effectiveness of pictograms. Furthermore, a fourth study was conducted in a realistic setting to confirm the generalizability of our results. In the control setting, we selected a vigilance test as the primary task to measure sustained attention, while attending to notifications as the secondary task. The video shows the apparatus and the user interactions. The user clicks on the target shape while attending to the text or icon augmented notifications. The primary task measures included hit rate and reaction time. Notification performance was measured using the IRC framework, which assesses the interruption, reaction, comprehension, and satisfaction of notifications. Our findings suggest that icon augmented notifications increased primary task performance. They were intuitive, shorter, and easier to recognize than text notifications, and the majority of participants preferred them. However, we identified a confounding factor. Text formats included extra words, while the pictogram format did not. By removing extra words from text notifications and comparing them with icon augmented notifications, we found no statistically significant difference, although the majority still preferred icon augmentation. This indicates that text reduction in notifications can improve primary task performance. Moreover, participants' unfamiliarity with icon impacted their performance negatively with the icon augmented notifications. In the third study, users were allowed to select icons to eliminate the effects of unfamiliarity. Surprisingly, we found that the user selection only matched 16% of the researchers' selection of the previous study. We also introduced encoding density as another independent variable. We found that icon augmented notifications were still more effective than text notifications, but encoding density plays a role. Although there was no significant difference in the secondary task, overall the pictogram format enabled better multitasking performance. Moreover, icon augmented notifications showed higher levels of comprehension, reaction, and satisfaction with lower interruption. To verify the generalizability of our lab study results, we conducted a fourth study in two realistic settings. mobile and stationary. We found that notification interruption and preference were not affected, but noticeability of notifications were affected by external brightness. In high external lighting conditions, the shorter icon augmented notifications were less noticeable than the longer text notifications. When using pictograms in notifications, designers should consider factors such as familiarity and encoding density. Our study suggests that pictograms are more effective when users are familiar with them and pictograms have higher encoding density. Overall, our study showed that icon augmented notifications reduce interruption and improve user satisfaction. This is due to the inherent properties of icons such as their compact representation, faster recognitions and ease of memorization and recall. Additionally, icons reduce cognitive load due to their simple patterns and are easier to perceive in suboptimal conditions such as shaking. To overcome the issues with unfamiliarity, designers can use standard pictograms or employ scaffolding techniques. Scaffolding involves showing pictograms along with text until users become more familiar with them before switching to icon augmented notifications. To increase the saliency of icon augmented notifications in outdoor environments, designers can add borders around the notifications or use contrasting colors. We used a simple transformation to convert text notifications to icon augmented notifications. However, we need to explore other transformation mechanisms from text illustration literature to support multiple secondary information. In conclusion, our study identified several factors that influence the effective use of icons in OHMD notifications. Based on our findings, we recommend using icon augmentation for everyday reminder or calendar notifications, as users can easily find matching icons to represent such recurring event. Thank you for your attention. If you have any questions, please reach us via email or check our paper using the QR code.